Have you ever wondered how the internet works? How do you get from clicking on a link to viewing your favorite website? It's a question that's crossed many minds, yet the answer is often shrouded in a cloud of technical jargon. Let's simplify it, shall we? Imagine the internet as a colossal global network of computers. These computers aren't simply connected, they are in constant conversation. But what language do they speak? They communicate using a common language called protocols. These protocols allow computers to send and receive data, ensuring the right message gets to the right computer. In essence, the internet is not a single, tangible entity. It's an intricate web of computers spread across the globe, all speaking the same language. They work together, seamlessly, to deliver the information you seek right at your fingertips. So the internet is not a single entity, but rather a vast network of computers all speaking the same language. Fascinating, isn't it? Imagine your computer as a traveler, setting off on a journey every time you click a link. This adventure, my friends, is the journey of data over the vast landscape of the internet. But how does your computer know where to go? How does it find its way from your living room to a server halfway around the world? The answer lies in the unsung heroes of the internet, the Internet Service Providers, or ISPs. ISPs are like the tour guides of the internet. They don't just provide you with access to the internet, they help route your data to its destination. They do this by finding the most efficient path, navigating through a complex network of routers, switches, and servers, much like how a GPS finds the quickest route to your destination. But your data doesn't travel as one large chunk. That would be like trying to navigate a city with a full-size map, cumbersome and inefficient. Instead, your data is broken down into smaller pieces known as packets. These packets are like little digital postcards, each carrying a part of the overall message. Sending data in packets has its advantages. For one, it's more efficient. Each packet can take a different route to the destination, avoiding traffic jams in busy parts of the network. And because each packet carries a part of the overall message, even if one packet gets lost or delayed, the message can still be understood. Once the packets arrive at their destination, they are reassembled in the correct order to form the original data. This process is a bit like putting together a jigsaw puzzle. Each piece or packet is essential to complete the picture. So every time you click a link, your computer sends out packets of data, like little digital postcards, which are guided to their destination by ISPs. It's a journey of data. Just like houses have addresses, every device connected to the internet has an IP address. Now, what's an IP address? IP stands for Internet Protocol, and it's a unique identifier for every machine using the internet. Think of it as a digital fingerprint, unique to each device. Every time you send an email, browse a website, or share a meme, your device sends packets of data through the internet. For these packets to reach their destination, they need to know where to go. This is where IP addresses come into play. They provide a unique location for each device, ensuring the data packets find their way correctly. It's like giving directions to a digital postman. But here's the thing. IP addresses are a series of numbers, and they're not exactly easy to remember. Imagine having to type in a sequence like 192.168.1.1 every time you wanted to visit your favorite website. Not very user-friendly, right? Enter domain names. They are the human-friendly versions of these numeric addresses. So instead of typing 192.168.1.1, you type in www.example.com. Much easier to remember, isn't it? But how do we get from a domain name to an IP address? That's where the Domain Name System, or DNS, comes in. It's like a phone book for the internet. When you type a domain name into your browser, the DNS looks up the corresponding IP address and directs your request to the right server. It's a seamless process happening behind the scenes, ensuring a smooth and efficient browsing experience. So, domain names and IP addresses are the internet's way of ensuring data gets to the right place. It's like the postman of the digital world. And just like that, every click, every search, every share is a journey through the vast expanse of the internet, guided by the unseen hand of IP addresses and domain names. Fascinating, isn't it? Ever wondered why we need web browsers? They do more than just display websites. Web browsers are like the magicians of the internet. Their magic trick? They take the raw, complex data from the internet and transform it into the visually appealing, interactive websites we see and use every day. But how do they pull off this trick? Let's delve into the magic behind the curtain. The primary role of a web browser is to request information, then display it. This information could be a web page, an image, or a video, among other things. Once the browser requests the information, it receives the data in a format that is, well, not exactly user-friendly. This is where the browser's magic comes into play. The browser interprets this data, often written in HTML, CSS, and JavaScript, and translates it into the visuals and interactive elements we see on our screens. It's like translating a secret code into a language we can understand and interact with. To communicate with web servers, browsers use protocols. You've probably seen these before: HTTP and HTTPS, which stand for Hypertext Transfer Protocol and Hypertext Transfer Protocol Secure, respectively. These protocols ensure that the data sent between the browser and the server is in a format that both can understand. HTTP is like the language of the internet, allowing browsers and servers to exchange information. However, HTTP is not secure. It's like sending a postcard through the mail. Anyone who intercepts it can read it. That's where HTTPS comes in. It's the secure version of HTTP. It encrypts the data, making it much harder for anyone to intercept and read. So next time you're browsing your favorite website, take a moment to appreciate the magic happening behind the scenes. Your web browser is tirelessly working, translating complex code into a language you can understand and enjoy. Web browsers are our windows into the world of the internet, interpreting complex data into something we can understand and interact with. So the internet is a complex but fascinating system, isn't it? A system where billions of devices communicate, exchange, and process information. We've journeyed together from understanding the role of internet service providers, those unsung heroes that enable our online adventures, to delving into the realm of data packets, those tiny bundles of information that zip around the world at lightning speed. We've also lifted the veil on IP addresses and domain names, the unique identifiers and friendly names that keep this vast digital landscape navigable. And of course, we've marveled at the magic of web browsers, our trusty digital gateways that translate complex code into the websites we know and love. The internet, then, is a global network of computers, speaking a common language, delivering packets of data to the correct IP addresses, all made accessible through our web browsers. Now, isn't that something to marvel at? Don't forget to subscribe, like, and share if you enjoyed this journey through the internet.